why don't you tell us a little bit about Algorithms IO before we get this up and running?
Yep. So thanks for joining everybody this afternoon. My name is Andy Bartley. As Professor Dasher mentioned, one of the co-founders of Algorithms IO. We provide predictive analytics for the Internet of Things. So what I'm going to talk
Oh, we got
about.
them.
Okay,
Great.
great. So I'm going to try and keep my comments brief and as jargon-free as possible. For those that have looked at big data, there's a lot of sort of marketing speak that goes around the space. So I'll try and tell you practically what we do in a couple of slides. I will talk a little bit about some of the things that are happening in the market with cloud adoption. And I've tailored some of those comments specifically to the Asian market. By the focus of today's conversation. That's a little bit more of an academic talk about what's going on in cloud computing. And then I have a couple of anecdotal examples based on our experience doing business now with some larger organizations in Asia on some of the ways that our approach to delivering these analytics as cloud services versus locally installed software products has innovated some of the traditional sales and business cycles that we see over in Asia. So, and again, I'm going to keep this high level, brief. I think what we're looking forward to today is your questions to dig into topics that are of interest to you. So if I move quickly through, keep questions and really look forward to discussing those with you afterwards. So what we do at Algorithms IO, as I mentioned, is we help make sense of the massive amounts of streaming data that's coming off of Internet of Things devices. For those that are familiar with the term Internet of Things, it's sort of a fancy way of saying any device that's connected to the Internet. These are things like monitors that sit on patient bedsides in hospitals collecting temperature and respiration. These are things like sensors that sit on manufacturing equipment, monitoring temperature and vibration. And there are also things like your smartphone, which collects accelerometer and gyroscope data. All of this data is streamed up into the cloud, into our service. And what we do is we build data models that turn these raw streams of data, and you can see above me, events per second and some raw streaming accelerometer data. We turn that data, that raw data, into discrete actions or events. And we let different industries customize those models specific to the industry. So we have predictive models for manufacturing to determine when equipment's going out of calibration. We have them for healthcare to determine when hospital conditions are leading to a higher risk of sepsis. We have those for wearables devices, so that by using a consumer wearable like a Fitbit, instead of just understanding how far you've run, the device can intelligently find out what you're doing at any given time based on the data being streamed off. So what we do is we make sense of sensor data. As I mentioned, we make it very easy to build classification models based on machine learning algorithms that turn that raw stream of data into specific activities or events and give you insights into what's going on. The classification step for streaming data is really important because until you understand what the data is telling you, you can't do things like drive business decisions. You can't automate factories. You can't make recommendations and actually give actionable insight based on that data. First thing you need to do is classify it. Once you've classified it, folks can understand how to actually take that inside their companies and act on it. So I mentioned at the end, I'll go back and run a quick demo just to show you some classification running with my mobile phone if we have time.
Actually, it'll work, I think.
I've got to log
Oh,
into
okay.
this. I'll do it at the end.
Okay.
Yeah, it'll be easier. So as I mentioned, what we do that's a little different than other players in the market today is that we provide all of these predictive analytics as a cloud service. So essentially, we combine the infrastructure of AWS along with the data scientists, along with the application developer. We wrap that all up into one package. So a company can get started with a full machine learning predictive analytics solution with a very low monthly fee. We actually have a free developer tier where folks can come in, can connect a device directly to our platform, can start streaming data in and getting results back within an hour. The data coming out of our platform is fed back into different reports, applications, and visualizations. So folks can take that information, either build great consumer apps based on hardware devices or use those for internal reports. The cloud platform, I'll show you here just really briefly. This is a high-level view of the architecture that we've developed. One of the things that we do that's a little different is that we abstract algorithms into reusable building blocks. And you can see that in our tier here. It's a little different approach to deploying algorithms inside the enterprise. Traditionally, machine learning is deeply embedded into core code of software applications. We abstract those out into these reusable blocks, and we provide some glue code that lets you combine algorithms written in different programming languages together very quickly. So say if you have 1,000 customers and you want to break those customers down into individual smaller units with the clustering algorithm, you can do that, and then based on those units, you can apply a recommendation algorithm written in a different language very quickly. So you can build these algorithm workflows on our cloud platform. I mentioned a couple of the use cases for our service today. We're working with a few consumer wearables companies. This is the Kiwi Wearables device, company out of Canada, and the Node Sensor company out of the Midwest. We're also working with some folks in energy and manufacturing, as I said before, building predictive models to help to understand energy consumption in manufacturing facilities and when machines are going out of tolerance. Also in the healthcare space, doing some predictive modeling to determine when certain conditions in the hospital lead to higher risk for certain types of infections that impact the hospital system quite a bit. So, why are we providing analytics in the cloud, right? Why aren't we going more the traditional enterprise model that analytics have been delivered in historically? So these are some numbers about the cloud analytics market today. It's about a $3 billion market, growing at a very healthy rate of about 26% a year. You can see up on the I think the bottom right or left, I'm not sure what it is from your angle, but some of the traditional players in the space. You see your SAPs, your Oracles, your IBMs in there. About a third of the cloud analytics market, though, is this other space, which is emerging companies like ourselves that are out there providing these analytical tools in a more lightweight, easy to use format. And we're providing those tools along with the infrastructure that you need in order to store the data. So you don't have to get your database from an Oracle and then your analytics from a downloadable SAP. We provide all of that to you in one complete package. For our talk today, an interesting thing to note is that behind the United States, which is the world's largest economy for analytics, Asia Pacific is second. So Asia Pacific is really driving a lot of demand around the migration to cloud. And the demand for analytics delivered as cloud solutions. And a lot of that is driven by Internet of Things and connected devices. So this is some work done by Cisco taking a look at cloud adoption in the US versus cloud adoption in Asia. And this compares cloud adoption for consumer cloud use as well as cloud adoption for business use. And you can see the business use of cloud, public cloud, is taxed pretty closely between the US and Asia. Both regions have a lot of hesitations with moving to the cloud. If folks have studied that space, there's a lot of concerns about security. How do I move from on-premise to the cloud? What happens about performance? And so the business side is run relatively parallel to each other in terms of growth. The interesting thing is that the consumer cloud usage in Asia Pacific, driven largely by wearable devices and a proliferation of mobile devices, is driving an incredible opportunity for new cloud providers inside the Asia Pacific region. An interesting thing alongside of that is sort of the economics of the cloud. So, if anybody studied AWS, they've dropped their price 19 times in the past 5 years. So we see consistent decreases in the pricing for cloud compute, but increased demand. So how are these cloud providers maintaining higher margin and growing their business? They're adding on value-add features. And value-add features are things like making Hadoop very easy to use, adding video transcoding as a service on top of cloud platforms. And these value-added features typically run about 20% more higher margin over standard compute. So a couple things in Asia, we've got higher demand for cloud, and we have this move to a more modular platform type infrastructure in order to add value-add services. So what we're seeing right now in Asia as a result of this demand for new consumer cloud infrastructure is that the several large players, and we've talked to about a half a dozen large enterprise players in Asia. These are companies that are not in the cloud market today, but they're all planning public cloud releases. So what we expect to see in Asia over the next 12 to 18 months is this rush to the cloud. And we expect to see a variety of new cloud offerings from very traditional enterprise organizations inside the Asian market. And these companies have had the benefit of studying what's happened with Amazon, what I mentioned before, that Amazon's had to reduce their prices 19 times in the past 5 years and have had to add on value-added services in order to increase margin. So what will be interesting to watch is as these Asian companies introduce their own cloud solutions, they're also looking for platform as a service solutions, analytics layers, additional value-add features that they can put on top of those clouds to help drive up and protect margin in those markets. So what that means is, have cloud, need PaaS, right? Sort of on the side of the road with the sign up, looking for that provider. So companies like ours that are providing a full analytics suite, the infrastructure along with the algorithms, along with the visualizations, fit very nicely into this evolving cloud economy over in Asia. And as a result of that, we've been in the fortunate position of speaking with a number of those companies, and we're moving forward with several, which we're looking forward to announce at the latter half of this year. And it's also how I came to meet Professor Dasher through some of those conversations. So.
Right.
Just wrapping up, so what does this mean in terms of disruption? I'll bring up 3 points that we've seen. Again, these are anecdotal based on our experience. First is faster, more customized pilots. This is very important in getting product out into the user's hands over in Asia. And what these pilots do today that's different, so if one of these larger companies wants to use analytics, is that with the cloud solution, you can highly customize a pilot in a matter of days that uses actual customer data. And this is very different from traditional pilot programs, trying out new technologies, which typically take weeks or months. What that does is it really shortens your sales adoption cycle. So you can see up top sort of the traditional sales cycle. And this is sort of a characterization based on our conversations with a variety of companies in Korea and Japan and China. It takes very, very long to bring a US-based technology into these markets. Typically 12 to 24 months is our experience. And I'd be curious to hear folks in the room have a different experience with that. But many meetings, internal debate, decisions, typically many folks involved in the discussion on whether to move forward. A small internal pilot, further discussion, then an external pilot with customer information, then more discussion. Then finally, if things work out, you actually get to bring a product to market. What we've been able to do by providing this as a cloud is go directly to proof of concept trials with direct customer data. So really bypass 6 to 12 months of internal lead time to bring new products to market. And as these companies are looking at this, they're realizing that they can break out of their traditional application development cycles of 1 to 2 years and actually bring new applications to market in several months, which is something that's very new for those economies. Final thing I'll mention is where are we at? This move to cloud is forcing companies to rethink how they calculate lifetime value, especially companies that have provided analytics historically. And this is true in Asia, and this is true here in the United States. So traditionally, a large amount of an enterprise software contract comes from services, service fees. So those are people in the enterprise that are working with these companies to help upkeep and maintain. When you move that to the cloud, you abstract away a lot of the complexities with managing these applications inside the enterprise. And so companies that are using analytics as a service are realizing that the lifetime value, how you extract value out of your customers going forward, is really about the value-add features, as I mentioned before, that you build into your offering versus those heavy service contracts. And that changes the dynamics and that changes the calculations around business model and customer lifetime value for a lot of these new companies in analytics. So we talked about a little bit about what we do at Algorithms, threw some stuff at you about the Asia market, what's happening in Asia and cloud adoption there, and also talked about some of the disruption we're seeing as a result of these new algorithms and analytics as a service business model. So try to keep it with a couple of topics pertinent to today. I'll leave it there, and then we can fire off questions here a little bit.
I think that's great, Andy. While I'm setting up for the next presentation, I want to point out, so we haven't had a chance to talk much about big data and big data analytics and cloud computing so far in the series. But with these analytics, companies are able to measure what people are actually doing online with their products or with advertising and so forth. It's giving companies, for instance, advertisers, amazing information about, empirical information about what people are actually doing, not only as they're watching that website, but every click that they will have later during the day. So it's a huge range of new data, especially with all the social media websites out there, and it's already really changing the kind of advertising and marketing industries. We have a presentation on that point coming up in a couple of weeks. What's interesting, though, is that right now there's a shortage of these people called data scientists who can deliver custom-made analytics to solve specific problems. Each specific problem really needs to be formulated in a very rigorous way. It's not just the knowledge of computer science that's important. And so a certain amount of customization is required for each kind of these analytics that's being developed. What Algorithms.io is doing is modularizing that process. And if you remember my talk last week a little bit about how the automobile wasn't really disruptive until the Model T Ford came along, this may be a similar kind of development in how analytics are developed. Because by modularizing them, you can reuse elements of code a lot better, and it becomes a much more efficient process. There is going to be this continuing need for customization, though. And with regard to the whole kind of customization area and how analytics that are solving specific problems work, we have another presentation today. And Divyabh is the CEO of CrowdANALYTIX, which is using another kind of very popular, radically new technique called crowdsourcing. And he's got a community of data scientists that a customer would pose a problem to, and then this community can come up with a good solution. Kind of like the Linux open source development community has got several groups that will do this kind of development. So Divyabh, would you give us some remarks here?
Sure, will do so.
Do you want to try to do this, or shall
I'll swap with you.
Okay, let's do that.
There you go.
I'll just take this up. All right, thanks, Richard. Hello, everyone. So just to give you a quick summary of what I will be covering today, Andy has already talked to us about what's driving big data growth. A lot of you guys have heard of big data. There is a lot of confusion as well out there. It's an evolving field. I'm not going to add my own perception to that to add to the noise. I'm going to focus on what we are hearing from our customers and primarily try to address the challenges that companies across industries are currently facing in adopting big data. Of course, Hadoop is there, the technology is there, and lots of new technologies is driving big data, but there are a lot of challenges that companies are facing, and I'll try to focus on that and how we are trying to address those challenges. And our experience has been across industries, so that kind of gives you a good picture of what's going on in various areas and which industries are actually doing better than others. But before I get into that, just a quick summary of what we are about, CrowdANALYTIX, because it is a new concept, and just want to quickly explain that to you guys. We now have a community of data scientists. As Richard mentioned, this is a scarce resource. We have people across 50 countries. More than 3,000 of them are now aggregated on our platform and are available for us to solve any data analytics problems. Now, there are problems that are, as far as the data is concerned, it's clear what you want, the problem definition is right and known. But there are many problems out there right now because this area is evolving. It's very difficult to know, firstly, how to even define the problem, how to identify which data sources to utilize. If it is the advertising you're talking about, if you want to predict a customer's behavior, which data sources are important? It's not an easy question to answer. Not only that, a data scientist has one perspective, right? He might be a great guy, but he still has biases. We eliminate those biases by getting the community to compete against each other. So any project held on our platform is held as a competition. And you will find hundreds of data scientists competing independently, coming up with solutions. And the best of those solutions are then delivered to the customer. So that's our process. We primarily look at public data because it's most of the data, by the way, the big data that you look at, most of it is publicly available. And the rest of the transactional data has always been there. So we try to focus on that. There is climate data, there is data on parking lots, there's data on accidents, crimes, real estate, social media. All of this data can give you immense amount of knowledge about companies and actionable insights. So that's the process we use. Just a quick thing on how it works. So any customer comes to us, there is a discovery phase. We engage with the customer, understand his problem. As I said, the biggest challenge is translating a business challenge into a modeling challenge. The two guys don't even understand their language, each other's languages. So for example, a data scientist is thinking in terms of modeling, and a marketing guy, and I have seen this across industries now. Marketing guy is not able to communicate his thoughts in a manner that a data scientist understands. This communication gap is what we fill through our solution managers. Once the problem is translated from a business one into a modeling one, this is then posed to the community. They come back with models, which we then package again as actionable insights for these companies. So a marketing guy is more interested in prediction of what a customer wants to buy, or he wants to know what is the ROI of his marketing mix, what is the most optimum mix that he should be utilizing. And the data scientist is thinking in terms of what data sets to utilize, how to clean up the data, how to merge different data sets. We fill that gap, okay? Now, this is a quick snapshot of the kind of people we have. So, yes, resources are scarce, and scarce across US and India or any other part of the world. This is common. Why is it scarce? And Andy will probably agree with me. Many of these mathematicians don't really want to be associated with one type of problem. Okay, they would rather remain horizontal. They're thinking numbers. To them, predicting the condition of a heart is the same as predicting the quality of wine. They don't care, and they would rather remain independent. So the best guys are independent consultants, and we've just aggregated all of them. Just a quick thing on how algorithms get optimized, right, on our platform within a very short period. So Andy talked about speed to market. Think of it as parallel processing of the experimentation process. When you're doing a new big data analytics, there is a bunch of trial and error phase that you go through. This happens in all industries, all organizations. When you are running a pilot, you will, the first step, you build a model, you try it out, you tune it, you test it on real data, you go back and do it all over again. If you're doing this with one data scientist, it takes a while. And that's one of the reasons the cycle times are as big as 12 months to 24 months. We are parallel processing this entire process, okay, of testing, trying, and tuning. So every time a model is developed by any of the data scientists, we update a leaderboard with their, in case of predictive analytics, we would have a prediction error, which clearly says how good or bad their algorithm is. Okay, the moment that score is on the leaderboard, the next guy comes and tries to beat it. Okay, this process is repeated. The benchmark keeps moving because it's a live public place where you're on display. And just like many of you, you want to do better than your peers. Okay, so the moment, let's say a guy in the US was on top of the leaderboard, by the time he wakes up in the morning, some guy in India or China has already beaten him. And then he wants to go back and do that again. This process is what...
While they're asleep.
Exactly. So that is what is shown by this curve, which shows how quickly, within 4 weeks, we reach a point where no further improvement is possible in the model, and this is the algorithm that gets developed and delivered to the customer. Okay, why is all of this required? Algorithms exist. Okay, there are 50 or 60 types of different algorithms across machine learning and statistics. There's nothing new about that. That's existed for a while, and it's been derived from artificial intelligence. The field of artificial intelligence, and there's just enough algorithms out there. What you feed into the algorithm is just not a science, it's an art, okay? And that is what causes all of these variations. And it's amazing how you see these variations, right? When you test it out on the platform. So just quickly, so that was a quick intro on how we do it, but I just want you guys to see where big data is as far as we are seeing, right? From discussions with companies doing fraud analytics, patent analytics, customer analytics. We've done climate analytics for prediction of flood. So we have a broad, experience. We've now executed about 40 competitions. This is where the industry is, okay? So people like Cloudera have ensured that the only thing Cloudera is doing is scaring the hell out of you and telling you, I hope
That's okay.
those guys are not there.
No problem.
Okay, so what they are doing is they're telling you, look, you need to keep all of your data. Okay, it could be data created by your video or audio or anything at all that you've been throwing so far or putting into your magnetic tapes. They need to be on your Hadoop server. Why are they doing it? Because unless you reach a scale of 1 terabyte or more, Cloudera is not needed. So what are they saying? Right, this is basically where it is, okay? I'm not exaggerating at all. So stop, when you're vacuuming your place, stop vacuuming it. Keep all the dirt with you. You never know, there could be a gold particle there somewhere that you are throwing along with the dirt. This is what Cloudera is telling people, okay? Now, post that, and this is where everyone is. So the fraud analytics guy, there are banks, they will say, look, before I didn't have all the technology and bandwidth, so all I did was randomly do some sort of fraud transaction analysis. Today, analyze each and every transaction. I have the ability to do so, so let me analyze each transaction. That's where people are heading. Everyone is stuck at first deploying their Hadoop itself. Okay, unfortunately, that's where the world is. So what do you do? That's one problem. The second problem is scarcity of resources. I've already talked to you about that. You can't find people. It's impossible. Most of the best guys are risk modelers. 60% of them are in financial services companies. That's where the most sophisticated guys have been. That's where they get the biggest salaries, and everyone else gets nothing. So that's another problem. Business execs and data scientists don't understand each other. Okay, this is just you can't talk literally. It's to that level. So, I went to this data-driven marketing event, the first one, by the way, in New York, and everyone has heard of predictive analytics, and everyone is there, saying that something is happening. Let me also be part of it. But nobody has a clue as to how to utilize it. Okay, so these were our initial conversations where we went and thought that let me go and talk to them and understand what they want. I got nothing, literally. They just did not know what they want. Okay, so what did we do? We went somewhat in the same route as Andy, but in our own way, where we are now pre-building certain solutions using the community. Okay, so we would rather give you business solutions than try to explain to you how all of this happens. Okay, and nobody gets it. And usually you're selling to business users. Data scientists don't even exist, as I said, in most of these organizations. So for example, right, just a quick example, and there are many that we've gone through, and this is definitely resonating, which is, think of it, this as a simple, and by the way, even this is not happening yet, right? So you have social media monitoring, you have people filtering information so that you can respond to some of your customers. There are sites that provide what your competitor might be doing, which is of value, but nobody is trying to identify correlations in all of the various data streams. If you tweeted on Tuesday morning, what is the probability or of it getting retweeted, say 10 times or 20 times? Nobody is telling this. Okay, it's why, and that's the question. That question is more important, and that is because people are taking the tools approach. And a tool can take you only that far because there are plenty of correlations. What we are doing is in real time on our server, we have 20 digital streams constantly being streamed. We look at a slice of time and we tell you what impact your tweet is having on your Google trend, or what impact your YouTube video like is having on your retweets. This is something that's impossible because when a community looks at millions of correlations, there is a need for some human intervention at this point to identify which is the signal and which is the noise. And there is always, a model will give you a bunch of correlations. Correlations is easy. What is the junk in there actually does require a guy with a magnifying glass, and that's what we are trying to do. Okay, so this is one of the kind of business solutions that is resonating with clients. Similarly, we are doing climate analytics. We've done patent analytics. That one is a very interesting one, where we analyze 22,000 H1N1 patents around H1N1 virus. As you know, these viruses keep mutating, and hence the vaccine needs to keep updating. So it's a huge process, and it's a very costly process for these guys. What we did is we looked at these 22,000 molecules, and we identified the top 22 or 30 that should become the starting point for building the vaccine. We saved close to 4 or 5 months of time in doing so. Because look, the fundamental pharmaceutical research days are over. Okay, there are many patented molecules, and usually a new vaccine is an amalgamation of those molecules. So smart grid analytics, just helping you look at energy data. And for example, you have these smart meters now and it's going to come in almost every house. And the energy usage is getting recorded. You know the signature of each device in your house. So you know when the fridge got turned on, or when the light bulb turned on, there is a certain wave pattern that gets created. We looked at this algorithm and we tried to split those signals so that we can provide itemized, almost like a credit card statement. Can we provide an itemized energy usage bill to you, where an air conditioner, you know exactly which device is consuming more energy, so that you can improve on it. Or maybe an air conditioning company can come back and tell you, look, try this out for free, your consumption will go down. So that's again, and CRM analytics. So we've looked at online customer behavior. And so recommendation engines are good when you've already, basically, someone has already bought a product. Imagine you have a new product and you have a new customer. I can tell you what is the likelihood of this new customer liking this new product. So we've done that for an online. So we've done this now across industries. And we worked in US and India. So I don't have experience in Asia, so I'm not going to talk about that. But in India, the core difference between US and India is the availability of data. Okay, the maturity and the availability of data is reasonably high in the US. Data is not easily available in India. And so the kind of problems we are addressing are very different as a result. In the US, for example, in marketing, we will focus on customer retention, churn, loyalty. In India, because there are two reasons. One is data is not available, and the second is it's a developing, evolving market. So they are more interested in, how do I acquire new customers? Can you get me data on that? How do I make my insurance agent more effective? So those are the sort of problems we are dealing with in India. But this is a quick summary and overview of what we are doing. Hopefully, it raises more questions than answers them.
So let me ask a question kind of as follow-up.
Sure.
You mentioned 3,000 data scientists who are in your community, and they're distributed over 50 countries. What is the scale in terms of number of people you actually have as employees or actually working full-time for the company?
Good question. So the full-time employees are only 10. And that's a very recent number. We've been managing with 4 people for a very long time. How do we manage that? Many of these community members are also appointed as lead analysts. It's a completely scalable. So the reason we've received investment, from someone like Axel, is because this is if it works, it's going to disrupt how people do things. Okay, you do not, the risk of having fixed resources is gone. If you want to try out And this is an area where trial is required. I mean, people are just in the beginning stages. So would you hire 10 very expensive data scientists in your company and have no guarantee of success? Or would you use a community like this and don't pay if we don't deliver?
Yeah.
Right? So it's a prize money based
Plus
thing.
you get to see many more possibilities
Many
of
more
what's being
possibilities.
delivered. Yeah.
In fact, even if I cannot do better than what you already have, that also proves something, right? The fact that 100 people tried and we could not beat your solution, it means what you have is pretty good.
When did you actually start? You've done 40 competitions, right?
Yeah, we started about 2 years back.
Okay. And so you've received venture capital funding.
Yeah.
Andy, your company is still at the stage of you're about to do the first round of venture capital, right?
Right. Yeah.
So in terms of what you both see as driving your respective businesses forward, you've both talked about the challenges.
Yeah.
What's really going to push it forward? What do you think? Is it the nature of the data, the availability of the data, or is it what's going to push it forward? Andy, why don't you go first?
Yeah, so for us, and we touched on this, with going more of the product route, so we're giving you sort of a pre-configured product. It's this platform with the infrastructure and the algorithms. It's important to pick specific target verticals. It's very difficult in this space to be a broad platform for the points that we just discussed, is that many of these problems, they look different, they feel different, they can be different within different industries. Different companies within the same industry are maybe trying to ask different questions. So not everyone's trying to ask the same question in different industries to get value. So for us, what's really important is to pick a couple of key verticals where we see some consistency between what the customers in those spaces look for. So where we're at right now as a company is speaking with 50 different companies. We've had 50 folks sign up for our streaming machine learning platform. And we're doing that validation right now of the market to see where we can find some consistent themes between spaces like healthcare, telecom, energy, manufacturing, some of these larger markets where there's an opportunity to build a product that serves multiple customers. But I think your move into looking to build full solutions, most people don't want to talk about data. It's not a fun topic. It's not a sexy topic. And it's not the way that most business people think about their company. Revenues not being generated because of data, if you think about it, it's, am I acquiring customers? Am I getting more value out of those customers? So the more that you can translate the raw data, ugly stuff into business terminology and business outcome, I think the more effective folks that I've seen folks in this space be.
Sure.
Divyabh?
Yeah. So whenever there is a technology and the value of the technology is clear, it's definitely going to happen. And it definitely is going to change how companies do business. Okay, there's no doubt about that. The challenges here are, so if you look at, I forget which survey this was, but the companies with the most investment in IT are the worst in knowing how their customers are doing. Why is the question, right? It's again, I go back to that same thing. They do not understand each other. It's not just the IT, and it has been with IT for a very long time. The first time when BI was introduced, it took ages for companies to just get their data together. So you had these data warehouses, you had all sorts of data marts built. Thousands of reports were being created, churned every day. Nobody saw any of those reports. The machine can give you the report. Unless you do something with it, it's useless.
Yeah.
Okay, so I do believe, and this is not just with big data analytics, but has been with BI and everything else. We need to feed the information in chunks that are consumable in small chunks to the business audience, and basically hide everything else. And once that starts happening, you will see better adoption because the value is clear. I think everyone knows the value, but there's this big frenzy. The CEO says, look, everyone is doing big data. Why don't you do it as well? And there's investment in IT. The marketing doesn't know what. So that's where the world is.
Okay,
right
sounds
now.
good. Let's open the floor. Questions? Go ahead.
So I have a couple of questions. First one, Is there something common between the companies that you see who are actually the first movers in the space, those who are trying to leverage it more ahead of the others? Is there something common about these companies? Like you said, the ones with the highest IT investments are probably usually the ones with the lowest understanding of customer. But what about the ones who are actually coming to these new platforms?
You want to take that? So I think the guys who have their data sufficiently organized already and have got a buy-in from their top management. I think top management buy-in is very important, and where the CMO has a greater say than the CTO or the CIO. Okay, companies like that tend to be doing better. For example, Macy's is a great example. They have literally taken it to the point where every pamphlet was personalized. Okay, now the CMO needs to have a lot of power in the organization for that to happen. It's political. A lot of these things are political, and how the organizations are designed. If everyone sees this as a data problem or an IT problem, it is never going to get solved. At least that's my view.
Yeah, I think another common theme that we see is that we see a lot of companies in older, more mature industries turning to data. So industries that aren't experiencing double-digit growth organically, that are looking for ways to, turn 2% growth into 3% growth or 4% growth. So, manufacturing, healthcare, or organizations. I guess healthcare is another good example that are under duress. So you've now been tasked with squeezing a large amount of inefficiency out of the system. How do you do that? There's only so many things that you can pull, low-hanging fruit you can pull off the tree before you have to start to get more analytical. So we see either, sort of market pressure driving this, either from a growth perspective or, in the case of healthcare, regulatory pressure driving them to think more critically about how to make changes.
Yeah, I don't have anything to add. Great question. Thanks.
This is about CrowdANALYTIX. You did mention that for the client, when you go ahead with some predefined solutions, it's often a lot easier for him to pick and choose. But don't you think that once the client gets such a solution, he often does not understand the intricacies of the model, and then so that might end up killing the product at the end of the day. So he might try it out without full understanding, and then might not work out as well as expected.
That's a good question. Our experience has shown that the client, and especially clients that do not have data scientists, let's say on the other end, okay, they're not even interested in the model. Remember one thing, these are perishable goods to a large extent, okay? Algorithms are dumb. The kind of algorithms we are talking about, that's why it's called machine learning. It's like a newborn child being fed with a lot of information, and it is that information that creates the algorithm. So they don't want the model. Usually what ends up happening is we get into a longish association where we keep updating the model for them, and they are more interested in the outcome, right? So as long as they're getting outcomes that are adding business value, they will continue to come to us. And as far as the model is concerned, we keep them away from them. Yeah.
Is there a related opportunity here for maybe educational programs for people on how to use big data? Or, you mentioned the solution managers in your staff. I would think that some of what they're doing is certainly advocating how to make use of the solutions.
Absolutely. Right? A lot of the discussions that we have starts off at a very high level. So it's not as if that might be because we are evolving as a company, and that's also because the client is evolving. So we go in there with certain ideas, and it's the solution manager that makes sure that we reach a point. You have to handhold and bring the client to a place where he's clear about what we are offering, and that it will add value. And usually it goes through a pilot phase, just like Andy mentioned. It's a trial and error. That's where they are today.
Andy, I want to follow up with you briefly. Your platform is really for people who would go on and do the final stages of developing the analytic solution, right? So, where's the handoff? Where's the best handoff between your platform and what people do case by case customized?
Yeah, so I mentioned that we typically start with a small pilot internally, and we run that with our internal team, with those customers. So we'll define and it goes back to, the previous comment about education. A lot of what we do up front is help people think like a data scientist as much as they're willing to extend themselves to do that. It's not always an easy task. Usually we walk in and they say, well, we have a problem, what's the algorithm to fix it? And that's not how the process works. So time is spent up front talking about what's the value of the data, what's the real problem you're trying to solve, and narrowing it. And usually the problem is about a dozen or more problems all encapsulated into one. And in about an hour or two, we're down to about an hour or two working with them, we can get down to a specific problem that you can actually build a model around. And then we'll deploy that internally. For us, one of the keys has been to work with customers at this stage that have internal resources that we can pass the baton to.
So it really saves them time. It really shortens that
Yeah,
cycle.
yeah, it's a teach a man to fish
Yeah.
kind of model. So we do that upfront consulting work with them, show them how to use the tool, and then we'll let them run with it, and we're available to be there for assistance as we go forward.
Okay.
Yeah.
And I want to
Yeah, we have several, but yeah, go ahead, Divyabh.
No, I just wanted to add to Andy's comment that the area they have chosen is very interesting. The data, the machine-to-machine data is where the world is heading, and that data is clean. Okay, clean data is a prerequisite, and because it's generated by machines, there are no gaps, and hence the analysis is much more predictable and accurate. So this is one area where you will see big data going. Yeah, sorry.
I saw your hand first.
Interesting presentation. My question is about the global expansion and the China expansion. So, what are the challenges do you face when you try to promote the products in China and in Asia? And then, what strategies do you use? How are your method of acquiring new customers in the States are different from doing the same thing in Asia? And what do you try to focus on when you market your product in China?
For us so far, the key has been partners. So we haven't entered any of the markets, Japan, Korea, or China as a newer market that we just lined up a partnership to go into without partners. And so we're working with larger established companies in those markets that understand the sort of the unique cultural aspects of doing business there. I think probably larger companies with more internal resources can go in directly. But for us, it's been a partner role. And with our platform, typically our platform is a white label solution, meaning it's branded for the customer that we're working with. So we really work behind the scenes, and we enable that customer to move the analytics that they're trying to provide into the cloud. So our platform is a tool that's used by that organization to move their analytics to the cloud. The end customer in those markets, we typically don't touch. So we're working directly with the business relationship. They help communicate those customer needs back to us. We get the platform set up accordingly, and then the end customer relationship is still managed by the company that has the relationships in that market.
Okay.
So China, I do not have a lot of experience. We've sold in India, and in the Indian market, the selling happens at a very high level. So in India right now, you have to sell the concept first, and only then do you get an entry. They are more interested in your data than your analytics. Okay, so if you have good structured data, that is of more interest because they know that once that exists, because they don't have it. So, but as far as the US is concerned, a lot of our discussions happen at a much lower level. So I'm talking mostly about marketing. Marketing, you find that there is a lot of leeway that say a digital marketing manager has in making decisions on buying products like this. So a lot of the discussions are with marketing folks as far as marketing solutions go. In India, it is not the case. I think that's one clear difference, as well as the market is evolving, so the problems are very different. the growth rate is humongous, right now. So if whether it's retail or whether it's insurance, banking, there's growth rates beyond say 7, 8, 10%. So they are more interested in acquisition, whereas here it's more about churn, loyalty, those sort of things, right? Customer
and-
value
And to
analysis.
get into that marketing budget, providing this as a service also changes the game in terms of how easy you make it for folks to do trials, right? So now a marketing manager can do a trial for several $1,000s, which means they don't have to run budget approval up the ladder,
Yes.
right? So you can get in, they can run it on their Amex, and you're in, you get your foot in the door, it's kind of your Trojan horse into the enterprise, and then you can grow that relationship over time, where traditional products, don't really allow for that.
A couple of related things. You had mentioned that 1/3 of the people providing analytics are really emerging companies, whereas SAP and Oracle are kind of the existing big players. I'm guessing that on the customer side too, the people who are the most robust customers are probably multinationals.
Yep.
And they do have the data already, including some of their own proprietary data as well as public data. And I'm sure they're interested in this combination of public cloud and private cloud. But one of the nice things about these two ideas is that this may open it up to customers that don't already have the capacity in-house to develop these kinds of solutions.
No, absolutely. And the price points are ridiculously different from what you find in traditional models.
But it is truly amazing how much big data work is going on in companies like Coca-Cola or Walmart. And
Yeah,
so-
Walmart Labs
Absolutely.
is just up the road.
Yeah.
And they've got a team of 30 data scientists working there, and GE has, I think, 100 or 200 data scientists now working out in Livermore, working specifically on Internet of Things. So these larger companies are making very, very large
And the power
investments.
companies are critically worried about how to reduce their maintenance costs.
Yes, absolutely.
So if they can predict when something's going to fail, that's,
Yeah.
Okay. Ed?
Can you each give us an example of the most interesting problem that you've solved? And I'm also kind of curious about the privacy policy when it comes to patient data in hospitals. The U.S. has very tight privacy when it comes to hospitals, very open on the internet, right?
Yep.
And the irony there is that may actually impede cancer research compared to, say, other countries which are able to collect the data.
Yeah, so I used to be compliance manager for Stryker, medical device company, so I'm very familiar with the data compliance laws. So for anything done on the cloud, you can obfuscate the data to be HIPAA compliant before it comes out to work with it. So you do have to take out any identifiable information from the data set. The interesting thing, anytime you have a regulation, it makes everybody very nervous. Most people don't know what it means, so most people just take the stance that we're not going to work with it. So I think in healthcare today, there's relatively few institutions that have a technical resource in-house that both has the technical savvy and the understanding of what the regulation means in order to be comfortable and understand how to work with the cloud. We probably count them on two hands, the institutions in the U.S. that do this. And one of the sort of leaders in the space is University of California, Irvine, a gentleman by the name of Charles Boise there, works with a lot of big data solutions and has built, and he's going to be open sourcing this next year, but really built a very interesting cloud infrastructure for ingesting streaming data from the hospital. So he has a real-time view of everything happening at every hospital bed inside the University of California Irvine health system. Uses Hadoop, uses some NoSQL to pull data out. It's very, very interesting stuff. So there is a sea change going on in the space in terms of thought and understanding of how to work with this data and also work with that in a more cloud open model. Right? Because he also realizes that trying to manage the infrastructure, the amount of healthcare data available is just massive. And you start to combine patient monitoring along with hospital ambient monitoring, and then conditions outside the hospital. So things like how does seasonality or temperature, wintertime, summertime impact inpatient rates, the types of infections and diseases going on. That's the kind of analytics that we want to get to in that space. And that takes larger data processing
Correlating very different data.
Yeah, and even regional impact, right? So what are disease states that are more prevalent here on the West Coast versus the East Coast, and how do those change with seasonality? So really getting down and micro into this.
So before we get off the topic of privacy, do you find that your solution to giving things to a community of data scientists, does that keep companies from coming to you? They're afraid of too many people knowing their problems?
Yeah. So uh, folks like compliance managers in various companies, they're paranoid about their data. There's no doubt about it. There are various technologies available to obfuscate the data, and to a point where nobody can even understand what it is, but they're still paranoid about it. So this is a problem that exists, and so we are focusing initially. What we do is we focus on public data and value from public data. That's where we are finding our sweet spot. But I have almost a philosophical response, okay, to the question, because I think the real question there is that if people were not so paranoid, and if these problems were given in an open innovation environment, would we not find answers quicker, right, to cancer or AIDS or any such thing? And that's a fact. Innovations happen better in an open environment. So I think people need to, the world, and this is a statement that I have made elsewhere, protection of IP was a key competitive advantage over the last couple of decades. But today, with the information availability, everyone has access to, and Google will make that access even more prevalent. So it is speed to market and the cost at which you got to market, which will determine, because it doesn't matter. I mean, it's getting faster and faster, where people are able to replicate your IP. Hopefully there will be a change or shift in mindset, which will focus more on speed and quality and the cost at which you get this done, rather than protecting something that is not even worth protecting, because it will become obsolete in 4 months or 5 months. That speed of obsolescence is growing. So hopefully that's where things go. The most interesting thing we've done is we've predicted the quality of wine. That was our first competition. That's how I got the community going. So my thought was, let it be something interesting which they've not done before. So we got a lot of physiochemical properties of grapes and where grapes are grown, and this was for a specific wine in Spain. And we basically created an algorithm that replaces the wine connoisseur, okay, and gives a score to all wines. So yeah, that was
Predicts the score.
Predicts the score.
You got a nasty gram from Robert Parker.
So that was interesting, yeah.
Disintermediate, yeah.
Did you want to mention a specific?
No, the healthcare work that we're doing, the work
Okay.
around sepsis detection is really kind of, I think, what's been most fun for us. Yeah.
Okay.
Yeah.
Go ahead.
So besides privacy concern, what are the barriers to adoption of big data?
Of big data? Big data itself, there's no privacy concern. If you're doing it in your adoption of our service, yes, privacy is a concern. But beyond that, the value of getting a lot of different eyes on a problem that is not fully defined in a period of time which is almost 1/10 of what would be possible in-house, at a cost that is, I don't want to get into cost in this conversation. I don't know whether it's fair or right, but it's a really low cost compared to what you would do on your own. So none of those are barriers. So the way we are addressing it right now is there is enough value to be given to you using publicly available information. Let me give that to you first. Right.
Yeah, back in the old marketing space, I remember how much money it was worth to a direct mailing company to increase their response rate from 1.5% to
exactly.
2%.
That's all. That's all they want.
This is a multi-million-dollar question for them.
Yeah. And we were able to increase it by 400% for one of the companies.
Okay.
From 1% to 4%, 5%.
Andy, what do you think?
Well, I was going to say, I wish the answer to the question was people's understanding of the value to get from big data. I think, like we mentioned earlier, most folks have made investments in Hadoop systems, but they aren't quite sure what to do with it. So they've kind of got the Ferrari sitting in the garage, and the keys are in it, and everyone's walking around looking at it and touching it, but no one's actually taken it out for a test drive yet. So it's, practically it's probably been, folks that haven't had the budget to spend, and the folks that have sort of spent the money on it. Now they have the infrastructure. I think where I forget, it's Oracle maybe just did a survey. I'm forgetting who did it, but 85 to 90% of big data installations right now are all in the trial phase, right? Not moved into production. So, I think for the folks that haven't invested, people are now starting to sit on the sidelines and wait to see, what is the outcome of all the investment that's gone into big data so far before they take the plunge. Which is why we let them do it online as a service, because it's a lot easier.
Does that mean that the ease of investment is large? That's why people are very
Yes, it is quite large. Yeah. And it does not. It just adds to your IT infrastructure. It does not replace anything. So your previous Oracle, your business object, they all remain. This is just one other thing you need to deal with.
So the early groups in this were the risk management people in the financial institutions. One of the things that we've seen in terms of industry cycles is that the companies that were doing social media analytics have been bought by the big firms like Oracle or like Salesforce.com. And so when you see the big companies buying up rapidly emerging companies, you definitely see that it's going mainstream. I mean, that's really within a couple of years of being something that they see as critical to themselves.
Yeah, it shows you where enterprises are spending money around big data.
Yeah.
So the social media analytics companies were able to go into larger companies and give a compelling story as to how the social media analytics can help your business. And enough of them were able to sell that story that all of a sudden an Oracle and a Google noticed and they bought a Wildfire, right? Or they bought a Buddy Media and brought them in-house because they said, okay, the social media story for big data is in place. It'll be interesting to see as there's other trends in acquisitions, you can see which areas of big data are starting to resonate and have business impact because they will get bought by these larger players.
Yeah. I saw another hand somewhere. Go ahead.
My question is for Andy. How much repeat business are you seeing from customers? Because being able to generate insights is one thing. Using that insight to get ROI in the company is another thing. So is it like once a company goes through one iteration, they're like, okay, this is working and gets back with a higher investment? Or is it like they take a step back to reevaluate what just happened?
Yeah, a little bit of both. So part of what we do is, like I mentioned before, start with a very specific use case, and then we grow that over time. So part of our strategy and go-to-market is to find companies that are big enough that we can grow with over time and that our platform can grow with. And then we look for industries where there's repeatability between different customers. So we look for problems where we can solve it for one customer, and we know that that problem also exists for other customers in the space that we can go resell that same solution to.
So just to kind of bring it back to Asia, do you see Asia as a major area for expansion?
Just speaking personally, yes. Yeah, we've got a number of pilots that are starting. For us, in our experience, the early adopter here has been Japan. Although I mentioned we're in conversations now with some folks in Korea and China as well. But Japan, there are a number of larger conglomerates that exist there that are looking at this cloud growth, especially the adoption of consumer cloud, and seeing that as a primary driver for their growth, especially folks that have traditionally been more hardware or enterprise software products. So that growth curve that I showed before is driving interest from Japanese companies and how to build out their own clouds and capture that business.
Divyabh, just for, be clear, I include India in Asia, okay? What do you see about in terms of expansion from this point?
In Asia, you're saying?
Yeah.
I mean, I'm seeing as much demand or desire in all our conversations in India. As I said, once they become more mature in terms of handling their data sets, and yes, cloud is one possibility. They're not as paranoid, by the way, as you find in the US, because the laws here are, the lawyer always comes into the picture, no matter what. But in India, as long as there's value, people will be more open. And I feel that's similar in Asian countries as well. We are trying to partner with a company to get into Singapore and Hong Kong.
Okay.
But it's similar. I don't think, once the data maturity happens, you will see a huge growth in Asian countries.
Okay.
Yeah.
Other questions? Go ahead.
What kind of incentives are there for the data scientists to actually participate and produce results in your function?
So apart from money, the incentive really is peer validation. It's a very different kind of bunch of people, right? They're driven by challenges. They're driven by more interesting problems. Andy knows that. And as long as you keep them challenged, and so we run a lot of self-sponsored competitions as well. Okay, we don't just rely on these mundane problems as far as the contestant is concerned, of just doing some sort of churn analytics. That's very common for them. So we always keep them occupied with more and new interesting challenges. That in turn helps us develop these models, which becomes part of our repository, and which could eventually turn into solutions at a later stage. Of course, the fact that they're mentioned openly, publicly on a leaderboard, that helps a lot. Okay, it gives you visibility, right? And you're being compared on something that you are good at, and you're being compared with people across the globe.
Yeah.
So,
what about open source? How does this fit in with the whole kind of open source movement in software? Both of you. Divyabh? Is the analytics being developed? The individual developers keep their IP? How does that work?
Yes, no, that's a good question. So, as opposed to the open source world in software, so like Linux or something where people just came together on their own in many ways and kept improving each other's code, we are just orchestrating that same phenomenon, right? Now, what happens is that when an algorithm gets developed on our platform, in return for the prize money, so if there is no prize money paid, that algorithm continues to belong to
whoever.
Yeah. Now, that algorithm does get transferred to us in return for prize money.
Okay.
However, because we are not selling the model, as I mentioned to you, we are selling the outcome of the model or the algorithm. Any gains that we get from that also get shared in the form of some sort of royalty with with these solvers. So that's another gain that they get, right? So if you're good at this, it's possible that if we grow, you grow along with us.
Yeah, I mean, open source is already really a key component of the data science community. So you look at the work done with R, most of that work is open. Apache Mahout, there is a lot of great algorithm libraries available today. And I think you made the comment earlier, it's not the algorithms a lot of time, it's the actual implementation of them. So understanding how to get the data into an environment where it'll actually work with an algorithm. And that's what a lot of what we do. And then in addition to that, you need the algorithm, but you also need all the infrastructure to ingest and store the data. That a lot of times is not trivial work. It's work that can be done, but it tends to look similar from company to company. And so packaging it up as a cloud platform abstracts away a lot of the unnecessary repeating of that work to set up the infrastructure.
So I think that we're about out of time, and what I'd like to do to end this up is just say, stay tuned, everybody. This is a really amazing emerging industry. It is growing at an amazing rate already. I think as people use more and more data from mobile devices, as people do more and more real-time analysis of what's going on, you're going to see more and more kinds of data feeding into these models, more and more correlation. It's really exciting, and I'm very excited that we could get both of you to be here at the same time.
Sure,
Thanks very much, gentlemen.
Yeah,
Thank you for having us.